All right. Hi, guys. We are going to do our first set of video notes today since the other half of your class is taking the test in class today. So you guys are going to watch this and fill out your notes with me. We are just going through notes number 1 for our Unit 2. And in Unit 2, we start working with inequalities and absolute value. But we're going to work on just graphing in this first part of the unit. And then the next unit, we'll actually start doing some solving. Okay, so the graphing really helps you kind of get an understanding of how all this stuff works, and it lets you see kind of a visual picture of it before we actually start solving. So these first 3 on here, we've got some simple inequalities. These should look very familiar from what you've done before. We did these in Algebra 1, but just reading this, so this first one, that is x is greater than 3, right? So if I want to graph that on a number line, different teachers have different requirements here. But all I require is that 3 is where we're going to use or do our cutoff. So 3 goes in the middle. I'm going to do one number bigger and one number smaller. Since it's just greater than means it doesn't actually include that number 3. So I'm going to do an open circle at 3. And then I'm going to shade where it's greater than 3. So bigger than 3 means I want to go towards the 4. So I would shade toward this direction. And I know everybody kind of has a different method of doing shading and such. As long as I can tell where your shading is, if yours looks a little bit different, that's totally fine with me. Also, make sure you kind of make that arrow really obvious and color it darker so you can tell where it's going. Okay. All right, then the next one, x is less than or equal to -4. So again, I'm going to make my number line here. I'm going to put the -4 in the middle. I'm going to put one bigger, that'd be -3, and one smaller at -5. This time it's less than or equal to, which means it does actually include the -4 in the solution. So I'm going to fill that with a closed circle this time. And then I want to go less than -4, so smaller or numbers smaller than -4 would be toward -5. My pen's acting up here. There it goes. Okay, so we're going to go that way. Okay, and then the last one we've got, this one actually says that 6 is greater than x. People tend to get thrown off by this. If this kind of throws you off and you're not sure which way you're supposed to shade, what I highly suggest is always rewrite that so the variable's on the left side. This is kind of like our symmetric property that we've talked about in the last unit. It's just with inequalities instead of with an equal sign. So I'm going to switch to put the x on the left side, the 6 on the right side. But if I switch those around, I have to flip my inequality symbol. So that would change to a less than sign. Right? If you think about it, 6 being bigger than x is the same as x being smaller than 6. Okay, so just be careful if the variable is not on the left side. And then I can graph that with 6 in the middle, 7, and 8. I want an open circle at 6, and I'm going to shade toward the left because I want to be less than. Ta-da! Right? Okay, so those should look very familiar from what we've done before in Algebra 1. Hopefully you remember all of that stuff. Now we're going to take those simple inequalities and we're going to see some compound inequalities. Compound inequalities are very similar to compound words. If you remember learning about compound words, that's where you take 2 words and you put them together to make another word. Compound inequalities are the same thing. You're going to take 2 inequalities and put them together to make a single inequality, or more than 2 sometimes. Okay, so there's 2 main types of compound inequalities. We've got and inequalities and we have or inequalities. And to know the difference between them, we'll kind of write it out in words and we'll do some examples. An and inequality means that I want something to be true and something else to be true. So this would be a solution or different solutions where, or I'm sorry, let's say that the solutions are where both inequalities are true. Okay, so for example, if I said that, my t-shirt has to be blue and it has to be a size small. It has to be both of those things at the same time in order for it to be the same, or in order for it to be true. Right? I only wear t-shirts that are blue and that are size small. So that has to be true. Okay. An or inequality is where your solution is one or the other. So solutions are where one or, oops, that's not how you spell or, one or the other are true, or is true, I guess I should say. Okay. A lot of times we think of this as adding them together, and we'll see, right? So it could be one or it could be the other. This is kind of like thinking like, well, my shirt could be blue and I would wear it, or my shirt could be a size small and I will wear it. So that means that you would wear blue shirts that are also larges and mediums and extra larges and extra smalls. Or it might also mean that you would wear shirts that are small and maybe they're pink or yellow or rainbow or whatever, right? So you're one or the other. So it kind of adds everything together. Okay, how these inequalities look. An and inequality can actually be written two different ways. One way is you'll just see the word and. So let's say I want to write that x is less than 4 and x is greater than -1. You might also see that written, a compound inequality, and you'll kind of see it two different ways. This first way is not as popular. Normally you'll see an and inequality written like this. You'll see it all as one inequality with the x in between. Oh, that's weird. There we go. Okay. So if you kind of read this, we had x is less than 4 and x is greater than -1. So if you think about the parts here, well, here's my x is less than 4. That's the same as that piece, right? And then I also have this part, and if I read that backwards, x is greater than -1, which is like this part, x is greater than -1. So you have both of the parts in one. And if you we'll kind of do this when we do the graphs, but a lot of times I like to think about and inequalities as x's between two values. Okay, then or inequalities, you'll only see these one way. We're going to see like something like x is less than 3, or that word or, x is greater than 5. And it's kind of simple to be able to tell which ones are or inequalities because you will always see the word or in the middle of the two inequalities. So it's pretty obvious which ones are ors. Okay, so now let's actually take a look at these and how to graph these and see how these compound inequalities work. Okay, so this first one, if I look at that inequality, I can see, okay, well, this is an and inequality, right? Because it looks like that one. And I can leave it this way. That's totally fine. We'll do it that way. But for these first few, we're going to kind of write out both of them so you can see what they look like. So I've got this first part. That one says that x is less than 3. And then I'm going to write and. And now the other one, remember, you just have to read it backwards, or I'm going to flip it around and say that x is greater than or equal to -9. Right? So I want both of these things to be true. I only want to like graph on my number line where both of those things are true. Okay, so now when I make my number line to figure this out, so we're going to kind of show work on these and then we'll draw a final number line. Okay, so for the first part, I'm going to make my number line here. I need a 3 on the number line, so put that there. And then I need a -9 on the number line. And on these compounds, that's all I ask that you put on there. Just put the two numbers that you need for where they start. Okay. Okay, so then I'm going to kind of draw a little sketch of where these would be. So the x is less than 3. Well, that would be an open circle at 3. And then I want to go less than 3. So I would shade that direction, right, to the left. The other one says that x is greater than or equal to -9. So that would be a closed circle at -9. And then greater than would be shaded to the right, right? Okay, now then, since this is an and inequality, I then want to find where those two graphs overlap. because I want it to be true for both of them. I want it to be true that x is less than 3 and x is bigger than -9. And the spot where those are both true would be right here where they overlap, right? So now I can go back and draw my final graph. And I'm going to put the -9 here and the 3. We want an open circle at the 3, because that's what we see over on our peak graph. And then we've got a closed circle at 9. And the only spot I want to shade is where those two overlap, which is in between the -9 and the 3. It's kind of why I said between up here. That's why I think of and graphs as between, because x is in the middle. And you can always, like, if you want to kind of test yourself to see, well, does this make sense? I'm going to pick a number in between these. So 0 is somewhere in there, right? So if I tested that, I could say, well, 0 is less than 3, and 0 is greater than or equal to 9. And now I say, okay, are both of those things true? Well, 0 is greater than 3, that works, and 0 is greater than or equal to -9. I'm sorry, I read that backwards. 0 is less than 3, that is true, and 0 is greater than or equal to -9. So both of those statements are true at the same time. That means that we've accomplished an and inequality. Okay. All right, let's try another one. Oh, and the answer to that is just this graph right here. That's what I'm looking for as your graph of that inequality. Okay, let's try another one. So the next one, this is also an and inequality, right? And again, if you'd like to write them out as the two separate inequalities, that's totally fine. So I'm going to write these, a different color here. Again, I've got x is greater than -2. That's this part, right? And then the other one is an and. X is less than 6. That one I'm going to read backwards or flip around when I write it. And then we're going to do the same thing. So I'm going to kind of show my work over here off to the side. So we've got a -2. And then we've got a 6 over there, right? Make sure you put your numbers in the right spot. That always helps. You don't want to put -2 where it's bigger than 6. So make sure you get them in the right place. Okay, and then we'll graph one at a time. So greater than -2. So I've got an open circle, greater than -2. And then I'm going to do less than 6. So open circle, less than 6 this way. And again, we're looking for where they overlap because this is an and. So where are both of those things true at the same time? Right in between those two numbers, right? So then when I go to make my final graph, I'll put a -2 there and a 6. Both of them are open circles this time, and then I shade in between. And again, you can always pick a test number there and then see if that one works. But it's the same thing. 0 is greater than -2 and 0 is less than 6. Those statements are both true. So we accomplished an and. Okay. All right. Now let's try an or inequality. This next one, I know it's an or because there's the word or right there, right? This one I don't have to rewrite out. I've already got the two different inequalities. So we'll kind of do the same idea here. We'll give ourselves a little sketch over here. And I've got a -1 and a 2 this time. And our first one says that x is less than -1. So I'd have an open circle at -1, and I want to go less than, so I'm going to shade to the left. And then the other one, I've got greater than 2. So an open circle at 2, and I want to go greater, so I'll shade to the right. So you see how different this one is from the and, right? The and, we had to look for where do those two graphs overlap? Where are they both true at the same time? But on this one, I want to know where is one or the other true. So, well, this one is true on the left side, and the other one is true over here. So I want to put all of that together now in one graph. So we make our number line. We'll put -1 here, +2 there. They are both open circles. And this time we're shading less than -1 and greater than 2. Okay, That's what an OR graph looks like. So if you wanted to pick, again, a test number, well, I could pick 3 is over there, right? So this time I would write 3 is less than -1, or 3 is greater than 2. Okay, and since it's an or, I just need one or the other to be true. They don't both have to be true at the same time. So the first one, 3 is less than -1, well, that's not true. But 3 is greater than 2, that is true. So I have one or the other is true, right? If I pick a number on the left side over here, if I pick a -7, well, -7 is less than -1, so our first one would be true, but -7 is not greater than 2. So it's only one or the other. Doesn't have to be both at the same time. Okay? So that's the big difference between an or and an and inequality. And you'll find the graphs tend to have the same pattern. And is always in between two numbers, or is kind of two numbers and then going opposite directions. All right, let's try a few more here on the next page. And we'll run into a couple kind of different situations to see what those look like too. Okay, so our next one, this time it's just written out as and for us. We don't have to separate it. So again, I'm always going to start with kind of my sketch before I make the final graph. And you'll get used to, as you get better at these, you won't always have to make a sketch for some of these simpler ones. But I suggest when you first start out with it, always make a little sketch for yourself before you make your final graph. Okay, so let's make our number line. We've got a -2 and a +3. I made an extra line. Okay, all right, so then we've got x is greater than -2. So that first one, I'm going to do an open circle, and I want to go greater than -2. And then the next one says x is greater than or equal to 3. So I'd have a solid or a closed circle, and again, I'm going greater than again, right? So now notice this time they don't go opposite directions like they did up on these other ands. This time they actually go in the same direction. But again, because it's an and, I'm still looking for where do the graphs overlap, right? Well, the graphs overlap here, right? And they both go on forever. Okay, so now when we make our final graph, I'm going to draw my number line. And we'll put -2 here and 3 there. And this time, actually, if you look at this, if I think about my final graph here, if I only want this spot here where they overlap, I don't really need the -2 on my graph, right? So actually, let's change that. And let's replace, all we really need on this graph is a 3, right? And then I had a closed circle on 3. And where they overlap is everything to the right side, and that goes on forever. So I would shade all of that. Okay, now if I look at this graph, if you want to put the other numbers on here, you could. That is much simpler than what we started with. If I look at that graph, I would just say that that is x is greater than or equal to 3. That's a much simpler way to state this inequality than what we started with. So if that's ever the case, then you should restate the inequality in a simpler version. So that would be our final answer on that one. Okay. Anytime you've got a simpler way to restate your final graph, you should do so. Math is always about taking the simplest route possible and making expressions as simple as we possibly can. Okay. All right. Next one. This is another and, right? So we're looking again, when we do our graph, we're going to look for where they overlap. All right, so we'll make our little sketch off here to the side. And both of these are at -2. So really all we need on our graph here is -2. The first one says that x is greater than -2. So that would be an open circle and shaded to the right. And the next one says that it's less than or equal to -2. So I'm going to fill that in. That would be a closed circle. And I want to go less than or equal to, right? Okay, so this one, they're both at the same number. They're going opposite directions. We want to know, where do they overlap? Well, the long arrows or the directions they go don't overlap at all. the only possibility we have for an overlap is right there in the middle. However, one of those circles is closed and the other circle is open, which means they don't have that number in common either. So this graph actually has nothing that overlaps, right? There is no overlap here, meaning that the two inequalities have nothing in common. So there can't be an inequality here. This is actually a no solution graph. And you can write that a couple ways. You can say no solution, or you can say the empty set, or you can actually write the empty brackets, right? And since there's no solution, then we don't need a graph, okay? And you can just kind of pick one of those three answers. I don't mind which one you want to use. A lot of times you'll see because these are graphs, you'll see these last two more than just no solution, but I'm fine with all of those. Okay. All right. Next one. Okay, now this one should look really familiar. It looks exactly like the one we just did, right? Except the inequality symbols are switched around just a little bit. So let's see what happens this time. Actually, that's exactly the same one, isn't it? Oh no, I'm sorry. The only difference here is it's an or instead of an and. Okay, I'll pay attention to what I'm doing. All right, so let's make our sketch over here to the side. Again, we only need the -2. And this time, we still got the same kind of sketch, so greater than -2 for the first one. And then our other one is less than or equal to -2, which goes that way, right? Except this time it's or. So that means only one or the other has to be true. It's not about the overlap. It's about putting all of it together. So if I put those two graphs together all on one graph, you can kind of think it as like smashing this down into one number line, right? Smash those two graphs down onto the single number line. If I do that, well, it'd be everything to the right side, everything to the left side, and that number that's in the middle, right? So in this case, every single part of the number line works, right? So everything works. And we know that answer. That one we can write, again, got a couple options here. You'll see all real numbers. A lot of times you'll see, or the set of all real numbers is really how we say that, or you might see it as x is an element of the set of all real numbers. Either way is fine with me. This one I can graph because it does have a graph, and basically you're just going to graph everything. So I tend to just throw 0 in the middle and then just shade the entire number line and make both the arrows big. Okay, so there's kind of an example of where you can still end up with a no solution or all real numbers on graphing number lines. Okay, our next two here, now we've got more than just two inequalities, right? So our next one, we've actually got 3 different inequalities, okay? So again, if you want to write these all out as the separate ones, so we've already got the x is less than 5, and then we have an and here. And then our others, let's see, we've got x is greater than -1, and, because anytime we see an inequality where the x is in between, that's an and, x, come on, is less than 8. Okay, so this time I have 3 different pieces. I've got the less than 5, greater than -1, less than 8, and they're both ands. Okay, so that means we want where all 3 of those graphs overlap. Okay, so let's make our sketch over here to the side first. I've got 3 numbers to put on my graph this time. The smallest is -1, and then 5, and then 8. And it's okay if you don't space them out perfectly as long as you put them in the correct order. And then we'll kind of go through all 3 of these, right? So x is less than 5. That's an open circle. and it's going to go to the left. Then we've got x is greater than -1, so an open circle at -1, and that one's going to go to the right because we're greater than. And then x is less than 8, so open circle at 8, and smaller, so to the left, right? Okay, so then since it's and, I want where all three of those lines overlap, right? So if I look for where I see all three of the lines, it would be right there, right? That's the only place on the graph where I see all three. If I go further to the right, only two of the lines, and then I get down to just one line. And if I go farther to the left, there's only two of the lines that I see there, or two of the kind of graphs. Okay, so then to make my final graph, we're going to make our number line here. And then I need, okay, so here's where we can decide what numbers we need. That 8 off here to the side, I don't need that because it's not part of where the graph overlaps. So really all we need is the -1 and the +5. And then you'll notice this one here has an open circle, so that's going to stay an open circle. And then here also has an open circle, so that one's going to be an open circle. And then our shading is in between those two numbers. Okay. And now again, this I can write a little bit more simply. Anytime you have an inequality that looks like this is always an and inequality when it's shaded in between two numbers. And you can think about that to rewrite your new inequality that's a little bit simpler. So what the easiest way I think to do these is you're always going to put your x in the middle and then just go ahead and put two less than signs, right? And these are going to stay less than signs. They're not less than or equal to because we've got open circles on both of our numbers. And then just put them in order. So the -1 would go here and the 5 goes there. So again, that's x is less than 5 and x is greater than -1. So that would be the simpler version of that inequality that we started with. Okay, so make a sketch, do your graph, and then you can write your inequality if you need to. All right, let's try another one where we've got a bunch mixed together here. And this time we've got an or and an and mixed together. And we've got some brackets also, and those are going to be important. So just like anytime you do math work, anything in parentheses is always the first thing in our order of operations. Parentheses or brackets, right, or grouping symbols. So we're going to do that part of it first, and then we'll look at the other piece, okay, or add that on. So this one you might even need to make more than one sketch, and that's totally fine. You're allowed to do that. So we'll kind of walk through. And like I said, you'll get better at doing these quicker and be able to see it ahead of time as you practice them. Okay, so first I'm going to do the or graph, right? So we'll make our number line here. And I've got a 4 and a 0, right? And let's see, we've got x is greater than 4, so that would go this way. Or x is greater than or equal to 0. So 0, that one will be shaded in because it's got the equal to, and I'm going to go that way, right? Now, if that's an or graph, that means that I want everything I see, we're going to just smush it down onto a number line, right? So that graph would actually just turn into, I want everything that's there, I have to go all the way back to the 0, and then I'm going all the way as far as I can to infinity to the right. So really all we need there is the 0, a closed circle, and to the right, right? Okay, then I can add on the x is less than 2 part, and this time it's an and, right? I'm going to throw the 2 on here, and I want to go x is less than 2. So open circle, and shade smaller. And now since that was an and, right, I'm going to write this over here. This was an or. This is an and. So since it's an and, I'm looking for where they overlap, which would be right in between there. Okay. So then I'm ready to draw my final graph. And on the final graph, all I need is the 0 and the 2. I don't need the 4 from the first part because we kind of included that in our other graph. So 0 and 2. And we've got a closed circle at 0, open circle at 2, and we're going to shade in between. And then again, I can write that more simply than how it started, just like we did the last time. This turned into an and inequality because it's shaded in between two numbers. So I'm going to start with my x in the middle, go ahead and put my two left-hand signs. This time, though, the 0 has that shaded in circle, so that needs to be an or equal to. The 2 is an open circle, so it's going to stay as it is. And then we've got 0 and 2. So x is between 0 and 2. And we've got our graph. Okay. These take a minute to get used to, but you'll get lots of practice on them. Okay, let's try then. We've got 2 left. I'm going to try a couple more complicated ones that take this even a little bit further. And now we've got sometimes 3 or 4. You can have 5 or 6 inequalities. You can have a bunch of these. Okay. Okay, so we're going to kind of do this one piece at a time. So this time, notice that I've got that set of brackets, and then I've also got this set of brackets, right? So let's kind of do those two pieces separately first. So we'll start with the greater than -2 or greater than or equal to 4. So we'll start there. We've got -2 and 4. Okay, so then greater than -2 would be an open circle, shade to the right. Greater than or equal to 4 would be a closed circle and shade to the right. Okay, and this is an or graph, right? So since that's an or, I want to graph everything that I see there, smash it all down into one picture, right? So I'm going to redraw that then. Make this one blue as just, there's -2, there's 4. And actually, let's think about that. Sorry. We don't really need the 4, right? If we're going to smash that all down into one graph, then really all we need is the -2. And it's got an open circle, and it's going to be shaded to the right. Okay. Okay, then let's go over here to this piece. Now we've got x is less than or equal to 5 or x is less than -3. So we'll start here. -3 and 5. And this time we're going to go less than or equal to 5. So closed circle going that way. Or less than -3. So open circle and again going that way. And again, this is an or, right? So I want to graph everything I see there. Smash the two lines down onto the number line. So that one. This time, I don't really need to draw the -3. I only need the 5 as my starting point. It's got a closed circle, and if I smush that less than -3 down on there, it would just be part of this less than 5 line. Okay. Okay, so now I've got those two pieces. Now the last step is to combine them together to get the and part, right? I want this one and this one together. Okay, so now when I sketch that graph, we need a -2 and a 5. We want to go greater than -2 because that's what that picture has. And over here we had less than or equal to, or that closed circle, 5. Okay, and now that's an and, so that means I want to go where they overlap. So that would be in between the -2 and the 5. So then our final graph here, we need the -2 and the 5. We've got an open circle at -2, a closed circle at 5, and we're going to shade in between those two numbers. And again, we can definitely write this in a much simpler way than what we started with. So I put the x in the middle, my two less than signs. The 5 has a closed circle, so I'm going to put an or equal to there. And then I've got a 5 and a -2. So there's our final graph and our simpler inequality. Right? Again, math, a lot of times with algebra especially, it's all about simplifying expressions. If I had to actually use this expression to solve some other problem in the future, or if I was trying to use this in, programming my phone to do a new task, I don't want to give it this big long inequality that will take my phone longer to calculate. But if I give it this shorter one, it will make it go faster and be more efficient. So it's simplifying that and making it simpler. All right, one more to try. And I might even encourage you here to maybe stop the video and try this one on your own. Take a pause, try it on your own, and then come back and watch the end to see if you get it correct. It's totally fine to get it wrong. You will learn a lot more that way if you try it and then see the correct way to do it than if you just watch me do it. I promise. Okay, so this last one, if you tried it on your own, now you're watching, right? Again, we've got two pieces in the brackets. So we've got this one that's an and then we've got that one that's an or. So I'm going to start by doing those two pieces separately. Okay, so the first one, there's -2 and a 6. And I want to go x is less than 6, so open circle to the left. And x is greater than or equal to -2. So that'd be a closed circle, shaded to the right. And then that one is an and, right? So if that's an and, I want where those two overlap, which is in the middle, right? That's our and. Okay, so then I could regraph that one as a -2 and a 6, closed circle, open circle, and in between. And you'll notice as you practice these, you may eventually get to the point where you don't need this step, especially for one like that. You'll probably just get used to the fact that if I see an and inequality, that means that I shade in between the two numbers, and that's totally fine. But if you have to do that step to start with, that's good practice. Okay, then our next one, I've got 9 is less than x, or x is greater than or equal to -20, or to +22, sorry, just making a line. All right, so draw a number line for that piece. And again, I see this 9 is less than x. I'm going to flip that around to make sure I get it right. I'm going to put my x on the left side, my 9 on the right, and I'm going to change that to a greater than. Okay, so I need 9 and a 22. Greater than 9 would be an open circle and going that way. And then greater than or equal to 22 would be a closed circle and going that direction, right? Now this time it's an or, right? So or means I want everything I see here. I'm going to put it on the graph. Just combine it all together. Don't get rid of anything. So really this greater than 22 or greater than or equal to 22 is just going to become part of the greater than 9 line, right? Just kind of smashing it all down onto one graph. Let me erase that. So this one, I really only need the 9. I'd have an open circle, and I'm going to shade to the right for that part. Okay, so there's those two pieces. Okay, then we've got to put them together with our or, right? Okay, so to put those together, and now I've got a -2, a 6, and a 9. So I need to put all three of those numbers on my next number line here. So we'll go -2, 6, and 9. And we're just going to put those pieces on there. So this first one here, I've got a closed circle at -2, open at 6, and it's shaded in between. And then the other piece over here, I've got an open circle at 9, and we're shaded to the right, right? And this is an or again, right? Because of what this was up here. So again, if it's an or, we're just going to smash all of that down onto the number line. I want to graph everything I see on that number line. So my final answer, or my final graph, I'd have -2, 6, and 9. And we've got a closed circle and an open circle and shaded in between. And then we've got an open circle and shaded to the right. Okay, and then again, just like before, we want to make a simpler inequality because we don't need everything up there. We can write this a little more simply, but there is two pieces this time, or there are two pieces. So this first part is where I've shaded in between. So that's an and. I'm going to put my X in the middle, my two less than signs. This one needs an or equal to because it's a closed circle. And then I've got -2 and 6. And then this other piece over here is X is greater than 9, right? Anytime you have more than one piece on your graph, they are always put together with an or. So we need that word or, right? So that inequality describes our final graph. We've got X is between -2 and 6, or X is less than 6 and greater than or equal to -2, or X is greater than 9. So that's our final answer there. Okay. Hopefully, if you tried it on your own, you did okay. If you got at least one of the pieces correct, good for you. If you had to make some corrections, still good for you. You tried it, and now you've made some corrections and you've learned from the mistakes that you made. Okay. Okay, so now that you've done that, there is a homework number 1 that goes with these notes. And for those of you who have not taken your test yet, that homework really isn't due until Monday, or when we have class the first time next week. I think that's on Monday next week. If you have taken your test already, then you should go ahead and start working on that homework. Otherwise, you may want to, again, if you haven't taken your test yet, go back and finish reviewing for your test and get your Unit 1 homework done before you get started on homework 1 for Unit 2. Okay. Enjoy, guys. Thanks for watching. I will see you soon.